Okay, folks, so now we're going to get into graphing, graphs and actually graphing our data, which is really important because we want to be able to make it easy for people to understand what we've done. So again, a variable is simply a factor in an experiment. The independent variable is the factor that is different between the two groups. Okay, so this is one of the ways that I remember it. My independent variable always comes after the if in my if-then hypothesis statement, okay? If I add iron to the hydroponic solution growing my lettuce, if I switch out decaf for caffeinated coffee in the faculty room, that's what I'm doing differently. Okay, that is my independent variable. It has two or more levels, okay, and levels can either be numbers or categorical. Okay, and guys, when we're talking levels, your control actually counts as a level. Okay, so that's why it says it has two or more levels. Your levels may either be, if it has iron or no iron, that's 2 levels. If you have no iron, 5 mgs of iron, 10, 15, and 20 mgs of iron, then that's 5 levels. Okay, so just letting you guys know. My experimental variable, okay, which is my independent variable, is always on the x-axis. Here's the thing, guys. Most of the time, it's going to look wonky to you if you put them on the wrong side. You'll be like, that just looks really weird. Okay, go with your gut if it looks really weird. My dependent variable is what is being measured. Mrs. Tompkins taught you guys that the dependent is what you're collecting the data on. I also like to say the dependent variable comes after the then statement. If I put iron in the hydroponic solution, then it will increase the lettuce yield per plant. Okay, I'm going to look at how much the growth increased. If I put decaf coffee in the faculty room, then teachers will be more irritable during the day. Okay, irritability would be then what I am studying in that case. That would be my dependent variable. It's almost always numerical. We really like it to be numerical because scientists like quantifiable data. Again, that's where when we get into psychology and stuff and it's hard to put a quantifiable number to it, that we tend to get the heebie-jeebies. Okay, and on a graph, the dependent variable is always on the y-axis. Now, as I recall, students in the past have told me that Mrs. Tompkins has taught you that this is the D and then this is the I. So dependent variable goes up there and independent variable goes down there. So if that's a good way to remember it, totally go with it. I have 2 common types of graphs, bar and line. Okay, basically if I have, if my variable is, if my independent variable is categorical, then it's going to be a graph, or I'm sorry, it's going to be a bar graph. They're all graphs. And if my independent variable is numerical, in that case, I'm going to be looking at a line graph. Okay. Sorry, that's just what I did. I got a little bit ahead of myself there, right? So bar graphs is when it's categorical, and line graph is when it is numerical. Okay. Because I will give you a quiz and you will have to make sure that you have the correct type of graph on it. So I choose a scale. Okay, I number all my grids evenly. Note that I don't always start at 0. Okay. Also, in science, unless they ask you to, you don't extrapolate data. In math class, you always start at like 0, 0 and work your way up. Science class, not so much. Science, you only start with your first point that you've actually measured. Okay, that's the only one you actually have information on. Okay, I have to label both axes. You guys, you will have points taken off if you don't label them. And you have to include the units in this. Okay, I plot my data. I connect my dots with a line. I could sing a really obnoxious Pee Wee Herman song here, and you guys probably don't even know who that is. And then I give my graph its descriptive title. Usually this has something, it goes back to my hypothesis statement. You know, it could be, you know, the effects of iron on lettuce growth, the effects of caffeine consumption on irritability, something like that. Okay, often graphs are like the effects of. We like that. And that's it. That's all you guys have to do with that one. That's a relatively short video.